Hey everyone, I wanted to provide a little critique of the Hyperloop system proposal. Well, I personally think it's a scam, but I'm a test engineer and I've worked in testing aerospace components and all sorts of high-tech gadgetry for 20 years now. And I've tested parts on the International Space Station and the old Space Shuttle program. So, and lots of aerospace components for Airbus, Boeing, Lockheed, all sorts of lots of aerospace. And reading over the original 2013 white paper, there's a couple areas there which are either extremely glossed over or just more or less, I have a hard time believing it was an oversight. It seems to be a conscious omission. So let me just jump into the white paper itself. Let's see. So you can see along with me. Okay. So you can see. Let's see. Let's jump over. This is the original white paper from SpaceX. This is what's interesting. This is from SpaceX. One thing that really worries me is this here, capsule depressurization, high safety standards, blah blah blah. Well, it says right here, in the case of more significant depressurization, oxygen mask will be deployed as in airplanes. Once capsule reaches destination safely, removed from service. Well, it says safety of the onboard air supply in Hyperloop will be very similar to aircraft and take advantage of decades of development similar systems. Considering this was on SpaceX's website, they really should know about the Armstrong Limit. And the Armstrong Limit basically is above about 62,000 feet, 1 psi, or 6.3 kilopascals. Doesn't matter how much oxygen you're providing, you just can't get enough in your blood with enough oxygen transfer to keep you alive. I mean, this proposed Hyperloop is going to be at 100 pascals or so, or even less than that for some of the ones I've seen. So that means the instant you have a depressurization, all the water and your exposed bodily fluids, saliva, tears, urine, blood, and the wetting liquids in your lungs will begin to boil. Yeah, that's right, boil. So it doesn't matter how much oxygen you're breathing, there's just not enough pressure. There's not enough pressure to keep life functions going. So unless they're going to repressurize the entire cylinder in about 30 seconds, everyone in the capsule will die. So it's kind of scary. And I mean, that's just, it's unacceptable. And actually, this was actually a problem on the Concorde they had, as it often flew about 60,000 feet, so which is right on the edge of the Armstrong limit. And it was part of their standard procedure if they lost cabin pressurization, just dip that nose down as fast as you can, because you need to get the pressure up high enough to sustain life, even with 100% oxygen. So this whole line of aircraft systems is bullshit, because this is basically operating in space. It's operating between 150 and 200,000 feet equivalent. So they know better than this. They should know better. It's SpaceX. They know how this works. The other kind of serious issue I see is the tube itself. I know Thunderfoot has gone on about thermal expansion coefficient, but it's just, he mentioned in here you'll need some sort of expanding accordion kind of style for the thermal expansion. that technology doesn't exist. Not even close. Not even conceptually. I mean, it just doesn't exist. And then other things which don't exist are compressors, which the 21 compressors don't exist. And all the designs I've seen so far for Hyperloop 1 and Hyperloop TT are both forego the compressor, and it looks like they're just drawn down to near vacuum. So that's one way to do it, but it just makes it much harder. Another thing that really makes me concerned is the estimates for some of the costs, where you can do 2-3 minutes of research and know that these costs are just absurdly low. I mean, just unbelievably low. You have the cost per capsule without, you see there's no factoring in development engineering, of 1.3 million, 3.5 million a capsule. An elevated car for any metro system or subway system start at 1.5 million a car. I mean, these things don't have to hold. I mean, there's rail cars. They don't have to hold an atmosphere. They don't have to travel 700 miles an hour on top of air hockey table type system or a maglev. I mean, just ordinary, you get on the subway car is 1.5 million a car. Tell me how you're going to do this 1.35 million with basically what's a spaceship. It's bullshit. It's complete bullshit, that number. And then the cost for laying down all this tubing is just exceptionally inexpensive. It's just, conventional rail lines cost $14 million a mile. I mean, it's regular class 1 railroads cost that much per mile. And he went on here about making this ride down a pressurized air gap in the tunnel, and just a very small distance too. I mean, just think a few hundredths of an inch, if even that. And that's, I mean, theoretically it would work, but you'd have to have a polished tube the entire length. I mean, the tolerances would be insane. It's just, it doesn't add up. And then you see, I mean, I know it's been beaten down before. There's so many things here that don't exist. This type of axial compressor doesn't exist. This intercooler doesn't exist. This high superheated steam condenser doesn't exist. The technology to transfer this off and on a vehicle doesn't exist. All these things don't exist. They're imaginary. They don't exist. It's just, lots of these numbers, from what I can tell, just made up, because you don't know what the power consumption is, because this doesn't exist. It's imaginary. And the one thing that really concerns me is someone like the Virgin Hyperloop. They're talking about using it for cargo. Why would you ever use this high-speed system for cargo? Most cargo is transferred by boat, or by barge, or by rail. I mean, how are you ever going to... It's just like... I was just curious, how much tonnage actually moves through, like, one port, the port of Los Angeles. Port of Los Angeles. General cargo, 184.3 million metric tons. How are you ever going to transfer that amount of cargo? And then other absurd things like the capacity of the system is the theoretical capacity is terrible. It's like, where was it? Oh my god, could you imagine riding around that? Oh, no way. The whole the numbers don't add up. forget how many people per hour he suggested. Something absurdly low, like 840 people an hour. It's where's the capacity? Sorry if I make you all sick. Oh, where's the numbers? Yeah, here's another good one here. This proposed route doesn't actually cross over the bay here, and the distance between these pylons is supposed to be at 100 feet. I can guarantee you there's going to be ships wider than 100 feet that are passing underneath this bay bridge. And yeah, see, 100 feet apart. But the capacity, where is it? I gotta find it. Bear with me a second. It's here. Here's your earthquakes and expansion joints. High-speed blah blah susceptible to earthquakes and needs frequent expansion joints to deal with thermal expansion. By building a system of pylons, the tube is not rigidly fixed at any point, and you can mitigate your, well, kinda, but you do about a minute of calculations. Even a day where you have this 20-degree Fahrenheit delta, the 350-mile tube length will take something like 120 yards. I mean, it really adds up. I just don't understand how you can miss some of this basic engineering. And you go to, I mean, here. In railroading, they have to deal with something called the sun kink. And there's huge amount of technology to deal with the buckling of, I mean, this technology is, I mean, this is well known, but the problem you run into is on a railroad, they have to go through all of these elaborate ways of pre-stressing the rails and all that to avoid what, I mean, railroad technology is 200 years old, and they still have this problem with thermal expansion because it's a physics thing. It's steel is going to expand and contract over temperature. So trying to say, wave your hands and say, oh, we're going to just have a telescoping tube similar to boxy ones used to access airplanes at airports will be needed at the end stations to address the cumulative length change of the tube. Yeah, like 1 to 300 meters of expansion. And again, this doesn't exist. There's not a telescoping tube in the world that holds a vacuum. The technology does not exist. And that means the tube itself would basically have to be on rollers on top of these pylons. And of course, you can bury the whole thing, but you'd be creating the longest tunnel system in the world in an earthquake zone. The engineering doesn't add up. And then, of course, I mean, there's so many, it's like, things that don't make sense. And it's like, I can't believe people are actually investing money in this. Because if you actually read through this, it's so underestimated and it doesn't pass. I mean, this is completely made up. And then you have, carries 28 passengers at a time. That's nothing. Oh, depart every 30 seconds during peak usage. Well, that's not enough following distance. You go in 700 miles an hour, you need more than 30 seconds to safely brake between two cars. I mean, you'll never get Department of Transportation even let you turn the switch on. And then they always talk about average operation. It's every 2-minute departure. So divide that by 4. So they only got a little over 5 miles of separation. There's no way you're stopping fast enough. It's just, I don't know. I don't know how money's getting invested in this, and it really worries me when I see pictures like Let's see. Hyperloop TT. I see images like this tube they built. I mean, there's no compressor on the front of it, so you're going to have to be running it in a near vacuum then. There's no propulsion method I can see. I don't know how the airlock, I mean, that's another issue. I don't know how the airlock's going to work on this thing. Oh, here's a big issue I haven't seen anyone really jump into, and that's pressure cycling. If you're not familiar with aircraft, they take up, they take off, they fly up an altitude, and they land. And that's a cycle. You're going from, I mean, there's a pressure differential between the cabin and the outside air. And they usually pressurize the cabin to something equivalent about 4,000 feet. So you got about 30,000, 35,000 foot differential on how many pascals that is. So every time you do that, it wears down the airframe. And conventional aircraft, you get about 25,000 flight cycles, and you have to derate the aircraft, and it's no longer going to be able to be used for safe passenger travel. So we're proposing a system now where you're going not from a differential of 30,000 feet to a differential of 160,000 feet. And if you're planning to use these capsules day in and day out, they're probably going to be making 30 trips a day, maybe more. And each time it has to do this pressure cycling. I mean, the amount of pressure, I mean, the amount of cycling in each cycle is probably the equivalent of, I would guess, at least 10 times more than a conventional aircraft sees. Conventional aircraft can only go 25,000 cycles. So you're looking at 2,500 cycles. So every 100 days you have to throw out the capsule. I mean, I don't see anyone testing this. I don't see anyone going, okay, let's pressure cycle these. Let's see how it stands up. I don't see that. I don't see airlocks being demonstrated. I don't see door hatches being demonstrated. I'm not seeing pressure cycling being demonstrated. And one thing I don't see is safety. I don't see life support systems. I mean, life support is going to be huge. I mean, this thing is a spacecraft. There's going to be a conventional aircraft. They use one of the compression on one of the jet engines to draw air in and compress it for the cabin. Well, you don't have that option when you're running at that level. 100 pascals or less. There's just not enough air in the tube. So you have to carry a complete life support system. You need carbon dioxide scrubbers, because that tube doesn't have a lot of volume. So you're going to be able to, you have to scrub the carbon dioxide out. It's a spacecraft. And if you have an issue where you get stuck in the tube, you can't even open the doors because there's not enough clearance between the walls of the tube and the capsule. You can't get out. So you're stuck in there until you can get to a safety hatch or something. I mean, you have to like physically move. I mean, I doubt they'd ever get any kind of safety approval on here. But I don't know why people are investing in it. And the test systems they're proposing are just like, why? Just build a maglev, build a high-speed rail, light rail, high-speed light rail, moderate-speed light rail. It'd serve you better, cheaper. Technology is 100 years old. I mean, you're reinventing the wheel. Why waste your time reinventing the wheel? I mean, this is just, it's a solution. It's a solution. I mean, there is a problem of convenient transportation between two cities, but we got we got airplanes, we have cars, we have trains, we have high-speed rail. You want to invent this fifth mode of transportation, and it's like, but combines all the dangers of space travel with all the dangers of aircraft travel with all the dangers of rail travel, and It's just I mean, there's a reason this idea is over 100 years old and no one's done it. It doesn't make any economic sense. As a little bit of, if you're a history buff, you know something about the United States actually had a version of the Hyperloop. It's not like the crazy fast Hyperloop, but it used to be something called interurbans, which went between towns in the United States. It was just electric, it was fast, it was comfortable, and it didn't make any money. It was killed by cars when cars came around. It was between about 1915 and 1930. There was a huge expansion of interurbans, and there's like 2 or 3 left in the United States now. I know the South Shore still exists in Chicago here, and I think there's a couple out on the West Coast, but high-speed electric, I mean, it was fast, it was convenient, it didn't have the last mile problem like you're going to have with Hyperloop. Hyperloop's going to have the last mile problem like every other mass transportation. I mean, that's the advantage of, it's like one of the reasons the Amtrak they're proposing out, the high-speed rail they're proposing out in California is going to be so expensive because it's going to dump you right in the middle of downtown. So you don't have to suffer that last mile problem. The last mile problem, if you're not familiar with it, is like, yes, you can get from point A to point B, but like, think of air travel. It takes you longer to get to the airport, go through TSA, wait for delays. Your actual time in the air isn't all that bad. It's just when you get off the plane, you got to get an Uber, or a taxi, or rent a car, and get to your final destination. And all those other steps can take far longer than the actual transit time. The transit time isn't the problem. It's that last mile that's the problem. So, I don't know. Poorly researched, and I still think it's a scam, especially when they start talking about, we're going to use this for cargo. Why? Why would you ever use this expensive, hard to maintain, high maintenance, high engineering cost, almost undoubtedly high labor need for transferring bulk cargo? It's stupid. I mean, you just throw it on a standard container and transfer from ship to rail to truck to end destination. It doesn't make any sense. I mean, it's like, so you really think these logistics companies are going to switch from a mile-long train with like 4, 5, 6, 700 containers double stacked on there to 1, 2? And I live in Chicago. We're the rail hub of the United States. Millions and millions of tons of cargo flow through the city and around the city. And it's just like, it doesn't make any sense. It's just like, I gotta call BS on anyone suggesting to use Hyperloop for cargo. It makes no economic sense. And then, I mean, even for passenger travel, it's going to be uncomfortable. It's going to be expensive. It's going to be terrorism, decompression dangers. It's going to be the most uncomfortable ride you ever. I mean, you can read some of the articles, some transportation engineers. It's going to be the most uncomfortable ride you'll ever have. I mean, half a G acceleration for like 3 minutes. Oh my goodness, I don't even want to imagine how rough that would be. And deceleration, the same. Do you think it'll be pulled up against your seat belt for 3 solid minutes? Oh, it's absurd. It's like they forgot that human beings are going to be using this, and that's the limiting feature. It's like aircraft. The limiting feature is not the airframe, it's the people inside. So, yeah. I mean, I don't know. The economics don't make sense. There's huge engineering holes in it. There's just so many unknowns which we don't have figured out. We don't have we don't have the expansion joint technology. We don't have we don't have the airlock technology. We don't have the compressor technology. We don't have, these things don't exist. And all the demonstrations I've seen of this stuff we know work already. Ooh, you accelerate a train using linear motor. Linear motors are 100 years old. We know it works. It's nothing new. We know it works. Then like a vacuum tube, which you pump down for half an hour. Yeah, we vacuums. We know how vacuums work. I mean, there's all the technology we know that works already. And that's all I've seen demonstrated. I don't see anyone demonstrating rapid pressure cycling of these capsules. I don't see anyone demonstrating how you're going to even turn these things around at the station. I mean, the white papers are just putting on a turntable. When's the last time we used turntables in railroads? 80, 90 years? I mean, it's just like... It's just 5 minutes of searching, it shows you half the stuff in the white paper is wrong. The numbers don't make sense. No one's demonstrating all the hard parts. No one's demonstrating life support systems. Show me a life support system. I mean, show me some MTBF numbers. Show me you have so many pieces of the puzzle which don't exist yet. And you're somehow going to say this is going to be 10 times cheaper than technology we figured out 100 to 200 years ago. If it was possible, it would have been done already. So, hey, if they can get it to work, great. I don't think you'll ever make money on it. I don't think you'll even get any kind of... I don't think the NTSB would ever let it run. I don't think DOT would ever let it run. It's just too many unknowns, too many dangers. And if you build this thing underground, you run into even more issues. How are you going to rescue anyone underground? 100 feet underground in a tube you can't get out of. And your air is running out quickly. It doesn't make sense. I don't know why people are investing in it. I really don't know. And yeah, space travel is very, 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 very dangerous. It's the most dangerous form of transportation ever devised. I mean, your chances of dying going to space is like 1 in 50. It's really bad. You're basically having general population going into space. I mean, you can say it's going to be safer all you want, but I don't even think government regulators even let you put a human... I wouldn't put a hamster in this thing. That's how dangerous it is. So, that's enough for now.